Alright, hey Honors Chemistry. This is going to be a very brief video where I talk about naming ionic compounds but with polyatomic ions and then writing their formula. What I would suggest you doing in your notebook is recording some of these notes down and then maybe even having the examples so when you take your open homework quiz tomorrow, you're able to answer some of the ionic questions and naming them and writing their formula. Following this video will be a very short Google form that has 2 questions related to this, just to make sure you're kind of getting the hang of that. They're multiple choice. All right, so a couple things. When I'm naming ionic formula with polyatomic ions, you always name the polyatomic ions as is. So the moment you find them on your list, you have a list of polyatomic ions that I gave you. The moment you find them on that list, you could name them as is when you find them in the compound. And then if there's a metal in there, you name the metal as is. And if it's a transition metal, be careful because transition metals need Roman numerals. And then if there's a non-metal in the compound, you change the non-metals ending to IDE. So if I want to name this compound Na3PO4, right, this is ionic. Na is sodium, and sodium is not a transition metal. It's on the far left side of the periodic table, so I would name it as sodium. PO4 is one of our new polyatomic ions. All right, PO4 is phosphate. I'm going to write it down here. Phosphate. And phosphate is a polyatomic ion that has a 3 minus charge. All right, and so why would there be 3 sodiums? Well, each sodium is Na plus 1 charge. So I needed 3 of them to give me an overall charge of 0 for a neutral compound. And so the way I would name this compound would just be sodium sulfate. For FeSO4 now, Fe is iron, SO4 is sulfate, and just as a note, sulfate is SO4 2 minus. And in checking the periodic table, I realized that Fe, iron, is a transition metal. That means I need Roman numerals in this name. So I have iron sulfate. Well, there's only one iron, and sulfate, as from the table that has all polyatomic ions, again, on Friday you picked up a handout that had common ions on them were polyatomic ions. If you don't have that handout, you could find it online what PO4 or SO4 is. So SO4 is sulfate. It has a 2 minus charge. Since this whole thing has a 2 minus charge, this must be 2 plus because the sum of the charges needs to equal 0. So if SO4 is 2 minus, that must mean Fe is 2 plus because 2 plus and 2 minus gives me 0. So this must be Fe2 plus. And so if it's 2 plus, I write iron 2 sulfate. That is how I name the compound. If I had a compound that had a non-metal in it, let's say NH4Cl, NH4 is the polyatomic ion ammonium. Again, you just write the name from the list. This is NH4 plus 1. And then Cl is chlorine. But if it's on the right side of the ionic compound, or if it's the non-metal, the ending always gets changed to IDE. So that ends up being ammonium chloride. Okay? All right. Now we're going to go backwards. And if I give you the name, can you write the formula? So let's try that. So for the rules for writing the formula, you have to treat the polyatomic ion as a whole ion. So you don't split it up, you don't put subscripts in the middle of them. You always have those atoms together. If there's more than one polyatomic ion, use parentheses. And this is what I'm going to quiz you on tomorrow. Formative quiz on if you could write them and making sure you don't forget what parentheses are for. And tomorrow in class, we're going to have a lot of practice with ionic compounds mixed with polyatomic ions. So here's how I always like to begin to figure out how to write the formulas. Ammonium is NH4 plus 1. Sulfate is SO4 2-. Again, where am I getting these polyatomic ions from? You have a table that was given to you, and I'm using the ones from up here, but you have a table that was given to you, or a paper, a handout that was given to you, or you picked up on Friday that has all the polyatomic ions that I want you to know. So I start off by writing ammonium, which is the NH4 plus 1 ion, the sulfate, which is the SO4 2- ion. I'm going to put like a fake circle around them. You don't ever want to split these up. This is just like what we were doing when we had simple binary ionic compounds, except now we have polyatomic ions. So for example, when I had Na plus and S2-, in order for me to write a compound, I could do the crisscross method, right? That could be like the little cheat I use, and I would need Na2S. Or if you didn't like that, I needed two Na pluses for the S2-, and then I would write Na2S because the sum of the charges needs to equal 0. We could do the same thing here. I could do the crisscross method, or I could notice how many of each I need. Well, looking at the both of them, this is +1 and this is -2. How can I add up all of the ions of both of them to give me a 0 charge? Well, if I have another ammonium, which is NH4 plus 1, I could have +1 and +1, which is +2, and then 1, 2-, and the sum of these charges would equal 0. +1 and +1 is +2, -2 is 0. If you didn't like that, you could do the crisscross method for this. This works. I'm going to bring down a 1 outside of the SO4, and I'm going to bring down a 2 outside of the NH4. Okay, so I'm going to need a 2 by the NH4 and a 1 by the SO4. Okay, I'm going to remind us of that. In general, I need 2 NH4s and 1 SO4. Here is how you write the formula if I need 2 NH4s and 1 SO4. It's going to be NH4, oops, the camera got a little messed up. It's going to be NH4 2, there's a 2 outside of parentheses, SO4. Same thing if I did the crisscross method. A 1 is going down by the sulfate. I don't really write 1s in compounds. And then the 2 is going on the outside for the ammonium, so I'll write NH4, parentheses 2. Okay? We'll do another example, and then after this video, just answer the 2 questions in the Google form. I could do calcium chlorate. Calcium, if I look on the periodic table, is Ca, and it's in group 2, so it's got a 2+ charge. Chlorate, if I look on my handout that has all the polyatomic ions, chlorate is -1. If I want to do the crisscross method to figure out what the formula would be, the crisscross method helps me figuring out how many of each ion I need to get a neutral compound, or the sum of the charges equal to 0. So if I'm going to bring the 2 over by chlorate, and I only need a 1 over by calcium. So I only need 1 calcium, and look at what I'm beginning to do. I need parentheses because I needed 2 chlorates. So it ends up being Cl, parentheses, ClO3, parentheses, 2. If you didn't like that, then I have Ca2+, which is ClO3 -1, and the sum of the charges needs to equal 0. Well, I have 2+ and I have -1. The only way that I could begin doing this is if I had maybe 2-, and that's needing 2 of the ClO3 minuses. So if I have a compound that has 2 ClO3 minuses and 1 Ca2+, the sum of the charges equals 0, and the formula would be written as CaClO3 2. Okay, well, I'm hoping this video kind of helped begin to figuring out how to name and write ionic compounds with polyatomic ions in them. We will go over more of this in class tomorrow, but watch this video, record these notes, and then answer the 2 questions in the Google form to make sure that you understand or kind of get the idea of how to name these compounds and write their formula.